Hi there, folks. Thanks so much for joining me today for the webinar on getting started with serverless. The plan for today's session is to go very quickly through what serverless means in a nutshell, and then do a very quick demo of how you can get started building your first serverless REST API with a couple of endpoints, just so you can see how it works, and then that'll give you the beginning points to continue from there. So, who am I? My name is Gareth McCumskey. I'm a developer advocate at Serverless Inc., the creators of the Serverless Framework. And I've been a web developer since about the early 2000s, building stuff for the web. And in 2016, I discovered the world of serverless and have been down that road ever since. And ultimately joined Serverless Inc. back in 2019 to help them with customers, help users, and so on build their serverless applications and kind of start working out the best practices for folks. So I wanted to start off the discussion today with what is serverless. And this is just a quick rundown in case there might be folks here today who have heard this word serverless but don't quite understand how it fits in and what it can do for you. So let's just take this from the viewpoint of a web application as you might build it today. And you've got a web application with many users potentially who want to access your application on the web. And traditionally, you would then have the browsers will hit first a load balancer. So you have some mechanism to allow load to be balanced, whether you use ALB in AWS or your own homegrown load balancer. What this load balancer is going to do is spread the number of requests across multiple virtual machines traditionally. And each of these virtual machines can now process based on the HTTP request that came in from the web. This is also fine. This also works in the Kubernetes world. Remember, Kubernetes pods still have to actually run on virtual machines, so it basically ends up being the same thing. And then your application in the virtual machines has to store data in some way. So that's normally done through a database of some type. And traditionally, this will also be backed up. So you'll have two of these machines sitting there for your database. One is a backup in case the master or main database goes down. But this structure is kind of cumbersome and time consuming because you may have got all of this infrastructure set up, but you haven't even started building an application yet or actually serving anybody. You spend all this time and effort putting VMs together, databases together, installing software, and so on. So serverless helps in this case because ultimately you're deciding on your infrastructure as you are building your application. It's not about building your application and then somebody sets up the infrastructure, gets hosted on. So what does that look like? Well, let's just replace what we've got here with a serverless equivalent, and we've still got our users over here interacting with our website. But instead of a load balancer that we've had to set up, configure, and maintain over time, we can use a managed service, for example, API Gateway in AWS, that allows us to receive all of this incoming traffic. And API Gateway exposes HTTP endpoints for our users. And this is really useful. This is not something that we have to ever worry about or manage or maintain. API Gateway is a service, and it just provides us enormous amounts of capacity to handle lots of traffic. And we don't have to ever manage it. Ultimately, though, you need that request to go somewhere to get processed. So instead of a cluster of virtual machines with CPUs that can then execute our code, we use a service like Lambda, AWS Lambda. And Lambda can receive all the HTTP requests from the API Gateway side and ultimately process each of those in parallel, which is pretty handy. Again, this means I don't need to worry about application software, operating systems, or anything like that. And then, of course, I need a database still, so we can look at a service like Dynamodb that's available in AWS. And Dynamodb is another managed service. I don't have to set up this database. I don't have to worry about scaling it, clustering it, anything like that. Dynamodb is just there to be used. You send it data, it stores it. You ask it for data, it gives it back to you. Easy as that. There's no management layer involved in Dynamodb at all. And the serverless framework is there to help you do all of this, because one of the downsides of all of this is that you have all these disparate little services that you might need to then configure yourself, go into the console or the API and patch these things together and configure them properly, and the permissions and IAM and all that stuff that can be a bit tricky to make sure you get set up. And there's some downsides to that. But the serverless framework helps you tie all this together nice and neatly and easily. What it does is it gives you a single configuration file, as you'll see, that helps you describe how you put all these pieces together in relation to an application you're building, not as a set of discrete pieces necessarily. This also lets you then very easily connect these managed services that we're using to for our application to the code that we're actually writing that ultimately gets executed in Lambda. It also means that because I have the single configuration file, I can now share this very easily with my team. I can hand this YAML file out, and everybody can use that. And ultimately, everybody can then reliably redeploy this same project in their own AWS account if they want to play around and test with, or in multiple different environments. It makes it very easy to reliably redeploy things as needed. And then in the long term, this then allows you to scale out and build really large-scale applications that can serve millions of users, as lots of serverless framework users have done. Because of the scalability of the services used in AWS, you don't have to worry about managing that scale. And because you have a way to manage your application and build it reliably, you also can then make sure you're building this application to scale for millions of users. So pretty useful in that way. But that's enough for the intro on serverless framework and serverless development. I want to actually get into the demo. So let's go ahead and jump right into that. So first of all, I'm going to come into my CLI here, my terminal. And what I'm going to do is I am going to get started. As you can see, I'm getting started, and I want to spin up a very quick template. So I'm just going to use the serverless command to do that. And this is going to let me choose a template to start with. I'm going to choose HTTP API as a way to get started. I'm going to give this a name. That's my API. This is now going to download this template for me. And there we go. Now, it's asking me, I am currently logged into the dashboard. The dashboard is an optional tool that you can add on top of your serverless framework development, and it has a lot of really great features that can make life a lot easier for you as a developer, and ultimately when you're in production as well. And because I'm automatically connected, it's asking which organization I want to associate my new service with. So I'm just going to choose the only one there. And it's also then going to create an app, which is essentially like a folder using the same name as my service, which I can change later if I wanted to. It's asking me if I want to deploy now, and that's one of the nice things. I already have a fully functional serverless framework service I can deploy into my AWS account. So I'm just going to say yes to that to get us started. And while I wait for that, I'm also just going to go into our new project. And let's take a look at the code. All right, so we're in VS Code here, and I'm going to take a look at some of these files that we've got waiting for me. So the serverless.yaml file here, this is the single configuration file that I was talking about. And here I can see I've got, I was talking about the organ app. This is where my organ app settings are added into my serverless.yaml file. Here's the name of the service that I gave it. I'm going to be writing my Lambda functions using Node 14. And this section here is where I'm now describing the relationship between my code and how they get triggered. So I'm going to have a file called handler, and you can see there's already a file called handler here. The function inside called hello. If I open that, you can see there's the hello function right there. We're not actually going to be using this file. I'm going to be replacing this in a minute. So what we want to do is let's build our own, and I'm going to build a customer API. Let's just assume I need a way to store customers and retrieve customers. So let's go ahead and do that. So first thing I want to do is I'm going to change this function definition here, and we're going to end up creating our customer because we can't retrieve anything if we haven't created it first. So let's go ahead and do that. And just for time, I'm going to just copy and paste something here, just so we can get this in quickly. The only thing I've changed is the file name is now going to be createCustomer.js, and the function name is also going to be createCustomer. And my method here is going to be a post, because with a REST API, if I'm creating, I'm using a post. And if I'm going to be creating a user, I also need a way to store data for my customers. Sorry, not users, customers. I need a way to store the data for my customers. So what the Serverless Framework allows me to do is use configuration details that AWS allows called CloudFormation. And what this means is I can describe my Dynamodb table that I want to create as a part of the service that I'm building. So here I've said I'm going to create some resources. The resource name is called customer table. The type of the resource I'm creating is a Dynamodb table. And because Dynamodb is a NoSQL database, I don't need to define the entire schema of the table. I can just define my access points, how I'm going to retrieve data. So here I'm just defining a single primary key, and that's all I'm doing, and then giving my table a name. Now, I could have left the name out. The Serverless Framework would have automatically generated a name for me, but I've decided to hard code or put my own name in here. All right. Now that I've got a database to store this with, I now need to provide the Lambda function the ability to retrieve the name of the table when we're running our code. So the way to do that is to use environment variables, and the Serverless Framework allows me to very easily add in a couple of lines here. So ultimately what I'm saying is here, here's a section of environment variables, and I want to create one called Dynamodb customer table. And I want this Dynamodb customer table to be equal to this value. You can see it's the same as the one down there. And this means that now when my Lambda function executes, I can retrieve that environment variable in my code, as we'll see in a minute. Last but not least, I also need to set up my permissions. And one of the nice things about serverless development is that by default, using AWS, your permissions are your Lambda functions have no permission to access anything in your AWS account, and you need to explicitly go and add those permissions. It seems a little annoying at first that it happens, but there is a reason for that, because you don't necessarily want this code to be executing that can have full access to everything in your entire AWS account. So here, I'm giving my Lambda functions permission to access certain parts of my AWS account, in this case, DynamoDB. And this is the specific DynamoDB table that it's accessing, the exact same table as we have here, for example. All right. That means we're pretty much set on the serverless.yaml page, but I also still need to create my file for create customer. So let's go and add a new file. I'm going to call this create customer.js. And again, I'm going to paste some stuff done earlier just to make things a little bit quicker. And all I've done here is I'm saying, let's export the create customer function. Here is the sort of format that Lambda functions are defined in, using an event parameter here. And this code essentially just reads data from the body of the post request, then sets up my DynamoDB database connection with the specific data that I want to put into the table. Here is where I'm using the environment variable to get the table name. Then I'm using my DynamoDB object to put that data into DynamoDB and returning it 201. Fantastic. Now that's pretty much done. The only thing that's missing right now is I've got here this const to require the Aws Sdk Npm module. Now I don't have that installed at the moment, so what I'm going to do is do an npm I --save Aws-SDK. We need to install the Aws SDK. And that's now done, so we should be good there as well. And now with all of this done, I've got my configuration done. I've got my create customer table done, function done. I'm just going to do an SLS deploy. And now this is going to deploy the changes I've made into my serverless framework service that I'm deploying. And while it does that, I'm going to go switch to the dashboard so we can take a quick look around there. So to get to the dashboard, I'm going to go app.serverless.com. You can see here is my service that I've added. My API has the dev instance that we deployed earlier when we got started. And I wanted to point some things out. You may have noticed that my AWS connection, I was able to deploy to AWS without a problem. Typically, what you'll end up doing is using the dashboard, you can go to the org section and set up a provider here to connect to AWS. So I could, for example, add a provider to connect to my AWS account, click Connect AWS Provider. It's going to open up my AWS account. And once I'm happy with these details, there's nothing that really needs to be changed here. I just need to confirm the box at the bottom, tell it to create stack, and then just wait for this to complete. As this stack is creating, I'm just going to refresh here to keep an eye on it. And when this has finished creating, it's going to end up updating automatically in the provider section for me. Let's just wait for that to finish. Just check on our deployment. We can see our deployment is busy going on here. Actually, might be finished shortly. All right, so that setup is complete. Let's go back to providers. And there we go. Our provider has been added. So we could use this connection to AWS instead of the local one on my local machine. And this is really useful to manage all my AWS connections together. All right, we've got our API endpoint is now ready. So let's just do a quick test of that. I'm going to make a quick curl on it, and I want to grab this. And I need to add the URL on the end, which is going to be this one. Really, all I'm doing is I'm using curl to push data at it using post. Also, no error returned. So that means that everything worked as intended. Now, I want to be able to retrieve this data, so let's do a quick get customer. I'm going to create a get customer file here. Close the CLI. And let's create some code to retrieve our data from Dynamodb. And again, this is relatively simple. Here, I'm setting up an object to scan the database, my Dynamodb table again. I'm telling AWS to create my Dynamodb object. I'm using the Dynamodb object to scan my database using these parameters that I've created here. Here we're just checking if we did actually have some data. If not, we're going to return a 404 status. And if we did, we're going to return a 200 and return the data, as you can see here. So I'm going to save that file. But we also need to just edit our serverless.yaml file here to update this. So let's go add the get customers function. And I'm going to just quickly grab here. And really, here's the file name, here's the function name. I just realized I need to rename this. This is get customers. And there's the function name, get customers, and this is a get request. So now with that saved and with get customers saved, we can once again do a deploy. And while that completes, one of the things that I want to just test out right now is if I come to Right, so we sent this call request before, and I want to, let's just say I remove name from there. So I have something that's missing that is required. This should throw an error. We can see there, internal server error has been thrown. And I just wanted to confirm, yeah, that was the same one. So if I go, one of the things is now I had that error, but I want to actually go check what happened with that error. So coming back to the dashboard is more than just managing the AWS account. If I go to the dev instance here, this allows me to actually look at the requests that have happened on this API. You can see I've done a bit of testing in the past here. What this is going to do is I can now see immediately that I have some errors that I could take a look at here. So I'm going to filter this by 15 minutes. You can see here's this error that I just created. So now I'm going to take a look at that error. I'm going to click through to there. Here's that error and create customer. And if I go back to, oh, that's the one I wanted. There we go. And I scroll through and I can see, oh yeah, here's one or more parameter values were missing. So my primary key just was missing at that point. So there we go. And if I wanted to, I can go see the entire log that was generated with the entire exception to allow me to debug that. So the dashboard actually becomes a very useful tool for debugging when you're busy building applications, but also becomes really useful in production when you need a more site, like 7 days worth of data. You can go back and see what the traffic looks like, what errors look like, and so on. Really useful feature to add to your serverless function. All right. So I've got my get customer function created. So let's go ahead and test that out. And that should be as easy as curl / URL. Let's grab the URL again. Oh, and we've got an error there. I know what the problem is. I did not notice, but I actually, where is it? Yeah, this is the environment variable is incorrect. So let's just fix that right up. And now I just want to redeploy that one function. So I'm using -F to say that function. And I just want to confirm is get customers. It is. So I can deploy just that function because I've just made a code change to the function, not the serverless.yaml file. So I'm just going to deploy the one function. Give it a couple of seconds, let it deploy that. There we go. Let's test that one more time. And there we go. We've now retrieved the data that is stored in the database. And so that is a very basic rundown with some debugging, some live debugging as it happened, which is pretty handy to see. And with the dashboard available to me if I wanted to go and investigate these details a bit more. So thank you so much for the time today, and I'm going to look at answering some questions now in a minute. If your question is not answered, or if you think of something later, please feel free to get in contact at gareth@serverless.com. You can even hop onto serverless.com/Slack, where there's a whole community of folks using serverless that might be able to answer any questions you have. So yeah, thanks so much. Let's go look at some questions.